Hi, everybody. Happy New Year. Welcome to 2025 and welcome back to the Chill Zone, where Don Gillis condenses the facts of working with Opteon low GWP refrigerants. My name is Chris Piles, and I'm going to be joining Don today just to help out. Thanks to each of you guys for taking the time to join us. We know your time is valuable, especially this time of year, so we're honored to have you with us today. Now, the transition to lower GWP refrigerants is here, and now is the time to get ready for your customers' questions. And that's really the point of what we're all doing here. Is we're trying to learn so that when we are put on the spot with questions, we've got the answers in our heads. Let's see. So if you guys do have any questions, please feel free to write them down in the questions box over on the right-hand side. And also at the same time, we're going to have some questions for you too. It's going to be a little to quiz you on the material, right? So you're going to have some questions. We'll answer them. We're going to have some questions for you also. Let's see. And let's see. I guess the last thing is, you might be a regular here. You might have done this for a long time, this might be your first time. But either way, sit back, relax, get ready to take some notes as Don Gillis goes and compresses all of this juicy information into your heads. All right, take it away, Don.
Thank you, Chris. I appreciate it. Happy New Year, everyone. As Chris said, we're going to be talking about retrofit today, which is going to be a big player in the future, as you know. Whether you're a wholesaler, a technician, 404A is going away, and it's going away very fast. So we decided we were going to choose a topic away from A2Ls today and talk about retrofitting. We're going to start out with retrofitting from 404A to R449A, and then we'll drop in some little tidbits there on some extra facts for you. So let's get started. A little bit of the agenda. Why consider retrofitting? The second part is going to be retrofitting with XP40, which is better known as R449A. And then we're going to touch a little bit on Glide. All this is going to be very high level. It's a short presentation. We only do this within an hour. We try to leave about 15, 20 minutes for questions. As Chris mentioned, throw your questions into the box there. That's what we're here for, to make this transition, all transitions, a little easier for you, okay? As we all know, the production, the allocations of all refrigerants, are all really HFCs, is going down rather quickly. We started in 2021, 2022 we dropped 10%, 2024 recently we just dropped another 30%. The idea is to be down to what we were at baseline in 2021, down 85% by 2036. These are the allocations for virgin refrigerant, or virgin HFCs, I should say, because there's a lot of things that have HFCs in them, but primarily refrigerant. Okay, so reclaim obviously too is going to be a big deal here, but the higher GWP refrigerants like 404A are going away, and they're going away fast. They've already done away with them in California and in Europe and those kind of things. So it's moving very quickly. This is the big one that's on the chopping block. So I want to start out by looking at some retrofits for the refrigerants we have out there. We're going to start from left to right. The first red box here is the low and medium temperature refrigerant for chillers. We can see up there at the top what's installed for HCFCs or HFCs, and you can see all the different refrigerants. Retrofit equipment option A1 would be 449. Notice the GWPs up here. Let's just take a look at 404A, for example, 3922, okay, compared to 1282. That's a big deal, all right? That's a big saver there. On new equipment, you'll see 454A, pardon me, and 454C. Those are Opteon products or Chemours products. We call Opteon is our new Freon name for the new lower GWP refrigerants. In the second red box, we see the air conditioning and chillers, and those will be for the R22407Cs. And then refrigerant chillers, we have the for 134A, which is typically used in medium temperature mostly, and the replacement for that will be 513A, another great refrigerant. We'll talk about that on another day. This was actually part of this presentation, and we had to reduce it down. But this is one of the best replacement refrigerants I've ever seen personally. And then on your new equipment stuff, you'll see the 1234YF, like in cars and what have you. Smaller charges it can handle as a single component on your blends, it'll be in a lot of the refrigerants moving forward, including the 454 series. Air conditioning, notice there's not a replacement here in green for the air conditionings for 410A or for R32. The new equipment will have either 454B or 54C, and then obviously on the air conditioning, we'll have also R32 in there. Now let's look at retrofitting with 449A. Why do we do this? Why retrofit to 449A? Now, I've been talking about this for a long time, clear back in the Copeland days. Potential for better capacity, and that's a big one. Okay, it can extend the useful life of the existing equipment. In other words, we don't have to tear out what's there now. We don't have to start with a fresh new piece of equipment. We can still get miles out of that equipment there. Environment enables accelerated transition away from refrigerants impacted by regulations such as 404A. I showed you the comparisons of the GWP. That's a big deal. And then avoids costly equipment replacement, improves the life of cycle cost of the equipment, prolongs those compressors, prolongs those coils and those kind of things. So you're not tearing anything out. We're not starting from scratch, and it's still a DX system, the same as it was. Okay, some of the benefits and basics of the 449 meets regulatory requirements. It's no ozone depletion. It's 67% lower in GWP versus 404A or 507 for that matter. It's commercially available and has been for quite some time. It's non-flammable, low toxicity. So in other words, it can be put into those existing systems that we have out there. We're not worried about mildly flammable or anything like that. Reduces energy consumption up to 12% energy savings. That's a big deal. I mean, we're going from a lower GWP and we're also saving energy, and extends the life of the existing equipment, replaces all the refrigerants you see there, 404A, R22, and medium and low temp. I want to emphasize that. And the biggest deal is major OEMs have approved it. Emerson, Bitzer, Carlisle, they've all approved it into their compressor manufacturers in their application engineers bulletin, pardon me. A quick glance at 449. Again, this GWP is 1397 compared to 404A at 3922. No ozone depletion, replaces 404A and many others. Okay, preferred POE oil, which is a nice deal. There's no change in the oil. ASHRAE 34 classified as an A1, A for the low toxicity and 1 for the flammability. And then if you care to know what's made up of the blend, the components that make up the blend, it's about 24% of R32, 24% plus of R125, and then 25% 0.3 of 1234AF. There's that 1234AF, and then 25% 0.7 of 134A. That is what makes up 449. I also put a QR code in if you want to scan this. It shows the thermodynamic properties of 449. It actually gets a little more in the weeds, but it's great information if you're having those conversations at the counter. As you all know, I did some time in the field, and I know how valuable the counter people are out there. Technicians really, really rely on you, as you know. I mean that sincerely. I think you all know that. That's where we get most of our information from. So the hope is you'll get more comfortable if you're not already comfortable with this, and be more comfortable selling it when we start to get really low in that 404A, okay? And just a side note here, I want to be very fair about this. 449A and 448A are very, very similar. The 448 has one other component in the blend, slightly higher GWP, but not much. But they act and respond pretty much the same. 449 applications: reach-ins, walk-ins, cold storage, ice machines, supermarket racks, industrial processing, anything you can think of. Again, there's an easy retrofitting guide right here, a QR code. All right, so some things to think about. We're looking at ice rinks also, and so on and so forth. Now, I like this slide. I made this up some time ago. Retrofitting considerations for easy conversion. What are some of the equipment goals? Let's look at the goals on the left-hand side. What do we want to happen that we can't do with tearing out a piece of equipment and starting from new? Okay, keep existing equipment running. Okay, in other words, very short shutdown time. The meat doesn't spoil, and so on and so forth. Simple and easy to service, the same as it was before. Minimum cost, maintenance, energy, And then total equivalent warming impact, sometimes known as TWE, the acronym, which means you take everything into consideration as far as maybe something you put in with a different system, say like a CO2 when it's running in transcritical mode, if you will. That's going to use a lot more energy. This is going to be pretty much like for like, and I showed you earlier, you're actually going to have a decrease in energy consumption compared to 404A. And then long-term compliance, again, keep the stuff running and also keep the equipment going. You know, those compressors out there, I've worked around them a long time. They last a long time if you take care of them with good service. And I mean, they're out there for a very, very long time. So you don't have to throw anything away. If it's not broke, you're not fixing it, okay? Refrigerant criteria. Safety of the system, okay? As what that means is we're not looking at something that's toxic. Let's say, I'm going to use some examples here. Let's say like ammonia, okay? We're not looking at anything that's flammable. Again, 449 is an A1. So we're not thinking about things like mildly flammable or propane even, okay? And then the pressures are going to be pretty much like for like, as opposed to something like, CO2, where you'll see 1,400 some pounds on the medium rack side, okay, going out to the cooler. An acceptable performance match, it complies with current and future regulations and compatible with existing components and materials. And that's a big one. This is the big one for me. It acts like what we're using now, very little changeover as you see as we're moving on. And it's going to be a good transition. This one is used commonly everywhere I go. People are already using this. You're probably very familiar with it, but we just want to reiterate what a big player this is going to be moving forward. It's going to be huge. So what do we need to do to convert over from 404A to 449? As far as the lubricants go, there is no change. We were talking about elastomeric seals, pardon me, I always butcher that word, or O-rings, there will be no change. Expansion valves. Now on the expansion valves, an adjusted needed and possibly a power head change. Some places are getting by with just adjusting the existing TXV, but we suggest just replacing the head with either a 449A or an R22 head for medium and low temp, okay? Always change the filter dryers out, okay? Even though we're going from a POE oil, we're gonna change the filter dryers out. Discharge tempers, review guidelines from compressor manufacturer once you make that change and see what you're shooting for. And then last but not least, once you get the refrigerant in, we're gonna adjust our set points for any possible glide or anything that differs from what we've already used. It looks like it's time for a chill zone pull time edition. Question.
All right, and here's the question, everybody. When retrofitting an existing 404A system, do you change the critical elastomeric seals? That is an interesting word. So the question goes back to a couple slides ago when we were talking about the things that are needed, what changes with your system or not.
It's a hard word
retrofit
to say, isn't it, Chris?
What's that?
It's a hard word to say, isn't it?
It is a hard word. My brain wants it to be something else, for sure. Alrighty, and thankfully it looks like 100% of our respondents are saying no, you do not need to change them out. So that's a good question for us. Thanks, everybody.
That's awesome. Thanks, Chris. Yeah, so either you knew that already or we did a good job of training. You do not have to change those. I'm going to say O-rings for the sake of not butchering that word again, okay? You don't need to change those gaskets and O-rings and things. That's a big deal because it's not like that for all retrofit refrigerants, as you know, okay? Let's look at retrofitting 404A to 449 once again. Some basic retrofit steps we're going to take. These are very, very crucial. Would like you to write them down if you can. Obviously, this will be on our YouTube channel shortly after. But the first and foremost, review the retrofit guidelines for 449A. Evaluate low temperature system demand cooling needs if needed. And then secondly, obtain a baseline data while running the 404A system, okay? Check lubricant level. So we want to check a baseline. Why do we want to check a baseline? Well, we don't know where we were at or where we're going if we don't have a baseline. We have to have a baseline first. So we want to document all that information. So when we get the 449 in there, we know what it looked like before, we know what it looked like after. And the reason I'm emphasizing this is I've seen too many times where people have changed the refrigerant and then say, hey, I got a problem. And then a tech support will ask them, well, did you have the problem prior to? And you don't know. So make sure you check the database, do the baseline check at the beginning. And I know that's common sense, but it happens all the time. People shoot themselves in the foot. Hey, mistakes are made. It's not a big deal. Recover the 404A, obviously. Change the filter dryers, as we spoke about earlier. Evacuate the system. We want to leak check it. And then follow TXV adjustment guidance. TXVs will need to be adjusted post-retrofit. And in many cases, a 449, or as I said earlier, R22 head would be the replacement power element, should be installed for the 404A. That's what we're going to suggest. Note at the bottom here, oil change and seal replacements not required. TXV adjustments on low temp demand cooling considerations are important, as we talked about earlier. Okay, charged with Opteon and startup and monitor. Now here's just some quick looks at some things here. Well, we're looking at 404A to 449 conversion. We've got our evaporator temperatures, evap temperatures here in the center. You're looking at PSIG. So at minus 25, if you're in low temperature freezers, you're looking at about 13 PSIG on the evap on the low side as compared to 8.9 on the 449. Let's just pick another one here. Let's say 22. So at minus 22, we're at 15 PSIG on 404A. We're going to be at 10.7. So you can see we're going to be a lot lower. The evaporator temperatures can be set by locating the desired average evaporator temperature or 404A evaporator pressure and determining the new set point required for 449 to achieve it, average evaporator temperature. So again, we're going to run a little lower, but once we get that 449 in there, we're going to look at the guidelines and adjust that the set points for the new system. And that's, you know, I know we all know that, but that's pretty common in everything we do. We have another question, another poll zone question, Chris.
Nice. All right, gang. When retrofitting with R449A, the first thing you should do is what? Either change the POE oil or establish a baseline or review the retrofit guidelines. Just toss your little answer on in into the little reply box, click on it. We'll be able to pull up and see how everyone's doing it. All right, we're looking pretty good. Oh, this is interesting, Don. So 67% of the group has voted. 50% of them said establish a baseline, and the other 50% said review the retrofit guidelines.
I knew that was going to happen. Yeah, I knew that was, I felt even this as late as this morning, I thought, well, I better get rid of that one because they're so close. But if you were to roll the tape back, you would see that you want to review the guidelines. But I can see where someone would say, you know, establish the database. But yeah, the way we read it off. So, you know, honestly, I would give points to both. And I thought about that. I really did. I thought, put something else in there. That's a little too close. But we want to review the guidelines. And obviously, if you're in the field or if you've been doing this a long time, establishing the database for the 404A is crucial and usually the first thing you do after reading it. Yes. Okay, let's move on forward. Frequently asked questions that we get all the time. Will fractionation cause any issues when using 449? No, the system effects of fractionation on refrigerants like 448, 449 are insignificant. Second question, what are the largest changes I'll need to make to my system, R22 or 404A? R22, you will need to change the oil. We're going from mineral oil to POE oil, as you know. Elastomeric seals will need to be changed. 404A, TXVs, we're going to talk about the head, as we said. Like I said, in South America, they seem to be getting away with adjusting the TXV. And is there going to be any demand cooling needs? More than likely not, but check with the compressor manufacturer. And then 402, 404A, oil seals, TXVs, demand cooling needs. How do I maximize energy efficient using 449? Factor for glide, use proper superheat subcooling measuring techniques, and then manage the set points. As you know, most TXVs are set for the for the superheat, okay, on the superheat for the dew point, okay, for 449, when they get into the larger cases and the more refrigerant, if you had a lot of glide in there, you're going to want to use midpoint. And that's pretty much what even some manufacturers that put out PT charts are already using midpoint. They don't have a dew or a bubble point on there. So that's one of the things you have to take in consideration, that glide. Since 448 and 449 are very similar, so can they be mixed? No, absolutely not. We're never mixing a refrigerant, right? Although similar in performance, different refrigerants should not be mixed, because what did we just do? We made a Frankenstein refrigerant, and no matter how close they are, your PT chart's really going to be useless, because eventually, and if people keep coming in and topping it off, for lack of better definition, it's even getting further away. So will my current leak detection system be able to detect new refrigerants? Any leak detector that can detect an HFC can be used with these refrigerants. As you saw the makeup of it earlier, those things are already on your sniffers, as we call them in the field, so you'll be good to go. Okay, so let's talk a little bit about glide, because that's going to be a bigger glide in the 449. Oh, it looks like we have a Chill Zone Pizza Party drawing first of all. Chris?
This is honestly my favorite time of the whole thing, because nothing like pizza. So every month, if you guys don't know, if you guys are new here, every month we select a winner at random out of all the attendees to receive a pizza party. You get a few pizzas, you get some sodas, it all gets sent over to your shop, that kind of thing. And so we've actually even got a couple winners here in the attendance as well. And we spun our little our little random attendee picker, and it came out with Angela Uli. And she's over at Baker, Don.
Baker.
Angela Uli.
Yeah. Yeah. Well, congratulations, Angela.
Congratulations, Angela. So I'll send you an email. You're going to get something from me in a few minutes, and it's just going to have some questions on there to kind of get the conversation going. But yeah, congratulations. And if you get pictures, send them on over. We'd love to see pictures of people having good food. All righty.
Yeah, that'd be awesome.
That's our winner.
The presentation next time, maybe. That would be awesome if you could send it. That'd be great.
Yeah,
well,
definitely.
Thanks a lot, Chris. Congratulations, Angela. All right, let's continue here. So I'm going to talk about glide. Now, I don't want to get all deep in the weeds here, but I just want to just really high level here. Refrigerant glide occurs when different components and refrigerant blends evaporate at a different temperature within the constant pressure of the evaporator, yada, yada, yada. It's simply put the temperature difference between the saturated liquid, the bubble, the saturated vapor. So in other words, if we find our evaporator, it's from here to here, from the TXV on outside, leaving the evaporator, okay? I wanted to share this with you. Here's the bubble point. The bubble point is this side of the saturation curve. I like to call it, refer to it as the thumbnail, if you will. This is the vapor side. This is the liquid side. This is the top of the saturation curve. Everything inside this curve or this thumbnail is saturated. Saturated by definition is what? Liquid and vapor in connection. It doesn't matter how much liquid or how much vapor. It could be 1% to 99% of either or, and it's still saturated. You know, you find saturated refrigerant in your tanks of gas on your truck, okay? So basically what this is saying is this is showing you the four-sided box, if you will, of the actual system. So we've got it coming through the evaporator. When it leaves the evaporator and then it becomes vapor heading into the compressor, that is our dew point, dew superheat, okay? We use that for checking superheat. We come up the compressor, we're raising the temperature, raising the pressure, and then we're coming into the condenser. We enter in the two-phase zone, where we start to condense, okay? And then we come across, we're rejecting heat as we leave the condenser and we're entering the metering device, okay? This is then our bubble point, okay? And then we come down, we're dropping the pressure. The TXV is the pressure dropper, if you will. We're dropping the pressure and it goes on and so forth and so on, okay? So I did this not long ago. I haven't really showed this yet, but just to make it real quick to give you a visual what that looks like in the system, okay? Starting with the compressor to the condenser. This is what the enthalpy chart, or the saturation curve, I should say, is showing you, not the enthalpy, but the saturation, okay? It goes to the compressor, we're coming across with the condenser, we hit the metering device, we go down to the coil, and then back to the compressor. So that's really what, so when you see these saturation curves and they're all messy with a bunch of lines, and you say, what the heck does that mean? It's telling you a lot of things, but this is one of the biggest things it's telling you right there. And the four-sided box, a lot of times they don't have the names in here. That's what it's telling you. That's the system. And I just kind of added this animation to bring it to life. Okay, so we're going to talk about glide. I'm first going to start out with refrigerants with no glide, a single component. Okay, so a single component refrigerant, I'm going to use the example here as water. Okay, and water actually has a refrigerant name. It's R718. When we come up the liquid line here, we hit our metering device. Water R718 boils at 212 at atmospheric pressure, as we know. And we're going to come across here, and we're going to start to boil away. All right, we'll start to boil. Let's say 75% liquid, 50% liquid, 25% liquid as we go through the evaporator. Okay, and then we should be superheat all the way out. Okay, so this is sensible heat over here. This is also where the superheat's going to happen once we hit 213 and all this liquid. Let's say it's a pot of water on the stove and it all boils out. As it boils off, it's changing state as it goes along. When we hit vapor, it will stay 212 degrees. That's latent heat. Anytime your heat that produces a change in state without changing in temperature, it will not change. Okay, when it hits 213, that means the last drop of water goes out there, and now we're completely vapor. And basically, gang, that is our industry at the basic fundamentals level there. That is the evaporator, as using R718 and a pot of water as the example. Coming back, we would have the condenser, the same song and dance. So we'd be going from the vapor and then condensing, changing state. All right, that is latent. Sensible is something you can sense. The furnaces are the contactor. Air conditioning set for 73. It gets 74. The contactor pulls in. It senses that 1 degree and therefore pulls in, calls for cooling. Okay, so let's talk about glide. We already talked about the single component. There's a method to my madness here. We also have refrigerants that we call azeotropic blends, components that boil off at the same temperature. Okay, so they would be in this consideration here. They boil off, as we talked about earlier, coming up the liquid line, boiling up through the evaporator, through the suction line, raising the temperature, raising the pressure. And then we have blends, okay, zeotropic blends, a mixture of 2 or more refrigerants with components that have different saturation temperatures. Could be 1 component or 2 components, could be 3, 4, 5, it doesn't matter, okay? A blend is defined as anything with 2 components or more. Could be as much as 5 or 6, as you saw earlier with 449. Typically, the more components you get in that blend, the more glide you have, typically. If you look at 407C, pardon me, it has a lot of glide in it. It's about 12 degrees in some cases there. It's 9 to 12 degrees. That's a lot of glide. I use that as the example because it's a refrigerant all of us are very familiar with, okay? Again, this is our bubble point over here on the liquid side, our dew points over here. So what does that look like for a blend? The first thing that's going to happen is the component that's most volatile or the highest pressure will start to boil off first. It's still staying as a blend, but that molecule or that component starts to change state from liquid to vapor first. As it goes on, the second component, the third component, all the way to the fourth component. The difference between the starting boiling point and the ending boiling point is in fact your glide, the difference of the temperatures. So it may be 2 degrees, it may be 6 degrees, it may be 8 degrees, or in the case of 407C, it could be 12 degrees. But that's what glide is. It's this difference between liquid saturation to vapor saturation at the end, start to finish of the coils in this case we're talking about, okay? Or the evap, I mean. All right, so here's just some examples of what glide looks like in some common refrigerants we use. Obviously, 410A has very little glide in it, so will 454B. 449 has 7. 407F and any of the 407 series, period, have a lot of glide in them. 404A is near azeotropic. A lot of folks don't like that term near azeotropic, but it's almost, it's about 1 degree or less than. Okay, so just something to think about. Temperature glide is significant in some refrigerants and need to be taken into considerations, as I said earlier. Typically, we strive for the higher glide. We look at midpoint as opposed to dew point, okay? Looks like we have another chill zone pull time.
All righty, good deal. Let's throw it on up and see what we got. Question for the team. How much glide is in 449A? Please select one. There's either 10 degrees of glide or 8 degrees of glide or 7 degrees of glide. That is a good question. That's one of those you got to kind of keep an eye open for. And the difference between 7 and 8 degrees of glide, Don, is that close when you're out in the field and you're looking at your gauges?
Yeah, it's really close. It is extremely close. Yeah, I probably should have separated them a little bit, but yeah, that's real close. You know, anytime you're within a degree, and glide can change if it's like, let's say, if it's in a heat pump mode to air conditioning mode of the same refrigerant. But yeah.
Oh, really?
Close. Yeah. Yes.
Oh, interesting.
It looks like 33% said 10 degrees, 11% said 8 degrees, and 56% of people said 7 degrees.
I believe the answer was 7, wasn't it, Corey?
Yes, the answer was 7.
Okay, very good. All right, well, good job, gang. I appreciate it. Great job, everyone. Let's go over the system checkpoint review. This isn't so much for 449, but just kind of a refresher, if you will, on things that we want to check for refrigerants. And these are things you would check, obviously, after a retrofit change out. I don't really like the term drop in. Sometimes it can mislead people, but that's the term we use. Okay, so we want to check our clean the condensers, verify airflow, the evaporators on both the condensers. Discharge temperature, pressure, suction pressure, we're going to check those, obviously. Check electrical connections, wire size, contactor, fuse, check amps, inspect piping for leaks, and correct size restrictions. Again, we want to check for leaks before we actually do the change out when it comes to the 449. Yeah, I think we touched on that a little bit already, but subcooling, we're going to check our subcooling. At the condenser, we're going to check the subcooling at the metering device also. We want to check it at the metering device, especially in commercial refrigeration, because that can change quite a bit if you have 300-400 foot of line set. There might be a slight difference there, and we want to make sure we have a full column of liquid going into the metering device. All right. Check for a temperature difference across the dryer, and check for moisture in the sight glass. Remember, we don't want to wait until it gets wet. We want to change the liquid line filter out when it starts to show a caution in the sight glass. Don't wait for it to get wet. All right, if it's at maximum, we want to do it before then. Temperature difference across dryers, pressures. We're looking at about 2-3 degrees is typically the useful. Remember, if you're doing pressures, if you have access to ports on both sides of that, you're looking at the same thing, around 2-3 pounds all there. Keep in mind, you're going to have about a pound of drop with a brand new liquid line filter dryer coming out of the box. So just keep that in mind. Take that in consideration, okay? Evaporator superheat, we're going to check superheat leaving the coil for the designer of the equipment, and then we're going to, for the compressor manufacturers at tech support, we're going to want to know what the superheat is entering the compressor on the system, okay? Those are going to be different, obviously. You're going to pick up some superheat as you come down, leaving the evaporator to the, what they refer to as total superheat at the compressor, by the way. Okay. All right. Let's talk about our training website. It's been revamped. A lot of good things going on. We'll go around the horn here. You can request virtual in-person training. We've got these recordings that we're doing right now on file. They're already in there. I checked it yesterday. I've been looking at it. The folks that do the heavy work or the heavy lifting behind the scenes, they're doing a great job with this. But you can also get your technical documents and resources. All this stuff is free, by the way. I don't know if I mentioned that. Our training's free. Optium pressure temperatures, guides for refrigeration, for air conditioning, safety data sheets, refrigerant replacement guide. This is a good one. Chemours refrigerant expert tool, and then get your tech tips there. Also, as always, for the 4th, maybe 5th year now, we've got Checkup with Dr. Chuck. Episodes, they're in season 4 there, it says it right there. About 4-minute videos on our YouTube channel. You can get it through our optium.com training portal now. I've been sharing a lot on LinkedIn if you haven't seen it. And now we also have this, the Optium Chill Zone webinars are through the porthole here at the training porthole. We're building that up pretty good. We also have one where they're going to release where it's like a Chill Zone minute that Chris and everyone's working on behind the scenes, and we'll have those short little videos similar to Dr. Chuck's, but just slightly shorter on kind of a did you know fun fact type thing. Okay, I believe that's the last slide I have. Any questions?
Looks like we just had a few questions pop up. Let's see.
Okay, all right.
Are the line set sizes changing on the new R454B equipment?
Not as far as I know. That would probably be a better question, equipment management. What I know is I have not been told anything extreme that I've heard of from any of the OEMs, but you'll have to check with the manufacturer, the equipment manufacturers on that. What we've been recommending in our training classes is this: if the specifications for the new equipment come in are specifying, let's say we have an existing 3/4, 3/8 inch lines in there already. If the new equipment is requiring that size and it's right, then we're allowing you to use the old line sets, or ASHRAE or every installations allowing you to use that in the guidelines. So, but as far as are they changing in size per manufacturer, I have not heard anything, but that would be something you'd probably want to address with the manufacturer. I don't think they are, but I would double check my work on that one there. I have not heard anything, and we've worked with all of them, and I haven't had anybody raise their hand in class and say, hey, Ream or Carrier or whoever, York or Train or whatever's doing this, and they're going to a different one. At one time, I do know American Standard and Train were talking about a smaller liquid line, if I'm not mistaken, but since then I think it was pulled back on. But please do your double check with the manufacturer that you're buying from. Okay, that's the best I can do on that one. What else do we have, Corey?
That is the only question that we had in the box. So we can move on if there's any closing statements. Otherwise, we can hang on the line for a little bit longer. And if you guys have any questions, feel free to pop them in that chat box.
One of the things I wanted to ask the audience was about topics. You know, we've got a long year ahead of us, and we can really dial in and get you guys some really good content on topics that you guys are interested in or that your customers are interested in. If there are any special requests, we'd love to hear them. We'd love to put together some a session or two based on what you guys are looking for out of Chill Zone. So if you do have any questions, any suggestions or stuff, just toss it down in the questions box, so we'll see it. We'll be able to capture it, and we'll be able to implement it in this coming year.
Yeah, that's a great point, Chris. I appreciate it. We want to hear what you want to hear. What do you want to hear? What kind of questions are you getting at the counter? Those kind of things. And then, as Chris said, just reach out to us and get those questions in there, and we'll make it a topic, or maybe we'll condense a couple topics together. But we want to give you the information that you need best. And I will do my due diligence to see if I can find, reach out to some OEMs to see if they're going to be changing line set size on 454B. I have not heard that, but that doesn't mean it's not true. So if you hear something, let us know. We've worked with all the OEMs thus far and have not heard anything about going up in size or low size. The pressures are fairly close. On the 454B, you're going to run a little lower. I know we're talking about 449 today, but the question was about 454B. Slightly lower, about 10 pounds on both sides. On the R32, you'll run just slightly a little higher. So it shouldn't make a difference right now, but again, double check. I don't want to lead you wrong.
Yeah, at a couple of the trade shows, Don, we had in some conversations, they were saying the danger essentially with this is if you've got an R22 system and you're pulling it out, and you heard somewhere that you can reuse the line sets, but clearly the R22 line sets are going to be different sizes. So, you know, if you're putting in a 454B system, you just got to make sure that the existing line sets are the right size for your 454B system. So just look at the specs. But yeah, if you're dealing with the R22 system, it's tough.
Yeah, and that's what I mentioned to him when you had broke off. Just read the manual. What we're telling folks in the training class is this: if the new equipment is specifying the size line sets you have already there in the existing equipment, what was there, you can use them. As far as material compatibility and those kind of things, as far as cleaning them, go through the same process you did before. If you're using nitrogen, which I like to use, go ahead and use that. If you're using some kind of flush like RX11, you can still do that. So nothing's really changing there. But you first and foremost, as Chris mentioned, and I said earlier, check the documentation, you know, make sure it's there. It's really the same practice we've used our whole lives. So.
Good deal. Well, that might be it.
That's it, Chris. I think we'll end it. And if you have any questions, email us in. Also, one last plug for the Opteon.com /training page. Go ahead, punch around in there, get yourself comfortable with it, familiar with it. And the other thing is too, on that note, what Chris talked about, if you see something that's not on there on the training page that you think would be a great asset to you and your team or others out in the field, let us know. That would be a great ad. Thanks, everyone. Thanks, Corey. Thanks, Chris. Appreciate your time. We'll talk to you next time.